Now, just to finish off from that last video, we were looking at equation of the line so far. So we're going to follow on from that and look at lines that are perpendicular or parallel to a given line. So I'm just going to do a couple of exam questions based on that. So remember, parallel lines always have the same slope, and perpendicular lines have opposite slopes. So we did that in one of the last videos, and opposite slopes means when you multiply the two slopes, you should always get -1 as a way of checking it. Okay, so this example here says find the equation of the line through the point -2, 3, which is perpendicular to the line 2x minus y plus 5 equals 0. Okay, so the first thing we're going to do here is when our equation is written like this, to find the slope, remember we get minus a over b. The point that we're going to be using is -2, 3. So if we look at the slope of this line here, okay, minus a over b means it would be -2 over b would be -1. So the slope here is 2 over 1. Now, if we're looking at a line that is perpendicular to this line, it means that this slope is going to be the opposite to that slope. So remember what we did in the last video, we end up just flipping the fraction upside down, and because it's positive here, the slope is going to be negative in this line. So our formula is y minus y1 equals m times x minus x1. So that's our equation of the line formula. So we're subbing in, labeling the point x1, y1. So we've y minus y1, so y minus 3 equals m is minus a half times x minus x1 is x minus -2. And the minus by the minus there becomes a plus. So remember, the denominator moves to the left, so we've 2 times y minus 3 and -1 times x plus 2. So we've 2y minus 6 equals -1x minus 2. Remember, you wouldn't get full marks at this point because you haven't fully simplified. So I'm going to bring everything over. So we've 1x plus 2y minus 6, and the -2 becomes +2 equals 0. So our answer would be x plus 2y minus 6 plus 2 is -4 equals 0. Okay, remember that you could be asked to write it in the form y equals mx plus c. So if we do, we leave the 2y on the left, we bring the other two terms over, so it becomes -x plus 4. And then when we bring the 2 over, it's going to be -1/2x, and the 4 divided by 2 is just 2. So they are your two answers there with the 2 ticks beside them. Okay, either answer would give you full marks. So similar type of question, except this time they're saying that it's parallel to the line. So it says find the equation of the line through the point -4, 0, which is parallel to the line y equals 3x minus 5. Now keep in mind, parallel means same slopes. And because this is written in the form y equals mx plus c, then the coefficient of x is your slope here. So your slope is just 3 or 3 over 1, but 3 is fine. So labeling our point x1, y1, and our formula y minus y1 equals m times x minus x1. So subbing in, we've y minus 0 equals m, I'm just going to write 3 times x minus x1 is -4. Okay, so that's going to become a plus here. Y minus 0 is just y. 3 times x is 3x, and 3 times +4 is +12. And that's your final answer there, written in the form y equals mx plus c. And you can see they have the same slope. which is what they had said, that the lines were parallel. Okay, so they're the two different types of questions that often come up in terms of perpendicular and parallel lines. Comes up quite a bit actually. Now, intersection of two lines. Okay, so in my picture here, intersection is where the lines meet. Okay, and these lines are going to only meet at one point only. Now, if we're finding a point of intersection, we need to find the value of x and the value of y. So in this diagram, I can't really pick the point of intersection from the diagram because my xy axis is not labelled, and often you wouldn't even be given the picture, you'd just be given the two equations of the line. Okay, and it's up to you to find the point of intersection. Now, to find the point of intersection, when we're looking at two lines, we are going to solve using simultaneous equations, which we have already seen in our previous algebra chapters. So this is why this topic is quite nice. It's a lot of substitution and a lot of algebra comes up. So for our simultaneous equation, we're writing down both of our equations. So 2x plus y equals 6 and x plus y equals 5. Now, if you remember, to do this, we need to either eliminate the x's or the y's first. Okay, for us to eliminate either the x's or the y's, we need to have the same coefficient. Okay, and we need to have different signs. And think about why that is. You know, minus 3x plus 3x is 0. So you'd be able to eliminate the x's. For this to be eliminated, it would have to be 2x minus 2x, which is 0. This one, y minus y. So the y's are probably the better ones to work with here because they both have the same coefficient of 1. So for us to eliminate, the only problem with the y's is we don't have different signs. So this needs to be negative y, but if I change the signs to the opposite sign, I need to do the same thing all the way across, not just to the y. So I now have y minus y, which is 0. So that's the y is eliminated. And step 2, now we're going to solve for x. So we're going to find our x value. 2x minus 1x is just 1x. 6 minus 5 is 1. So your x value is 1. Step 3, sub in your x equals 1 to one of the equations. It doesn't matter which one you pick. I'm just going to pick the first one. So 2x plus y equals 6. We now know x is equal to 1. So it's 2 times 1 plus y equals 6. 2 times 1 is 2 plus y equals 6. So y is equal to 6 minus 2. So y is equal to 4. And what that means is the point of intersection for these two lines would be 1, 4. Now remember, looking back at simultaneous equations, that's the most straightforward type of simultaneous equations you'll see. You also see simultaneous equations when you're finding intersection points of a quadratic and a line or a circle and a line. So they're a little bit more challenging. They're the easier ones. Okay. Now, area of a triangle. Okay, so there's two different examples we're going to look at here. First of all, our formula is half of x1, y2 minus x2, y1. Okay, now we're going to be given 3 coordinates, but the formula only uses 2 coordinates. So we don't run into a problem here, but in the next question we will, and I'll talk a little bit more about that. These absolute value bars in the formula, okay, so the bars here, they just mean that because this is a real life problem, you're allowed to always make the answer positive. So if inside here you were getting minus 22, you'd be able to change that to plus 22 because it's a real life problem. You're finding the area of something, so your answer cannot be negative. Now, if we look here, example 1, we have 0, 0, minus 2, 1, 3, and 4. Now what that means is if I did a rough sketch, okay, the triangle is going to have one vertex at 0, 0, minus 2, 1 is the second one, and 3, 4 is the third one. So obviously this is not accurate, but just so you get what we're looking at here, we're looking at the 3 vertices of a triangle. So when 0, 0 is one of the vertices, we just use the other 2 points and sub into the formula. So what we now have is x1, y1, x2, y2, and we're subbing that in, and I'm opening up brackets for each of those variables here, x1, y2, x2, y1. So x1 is minus 2, y2 is 4, x2 is 3, and y1 is 1. So we've half of minus 2 times 4 is minus 8. 3 times 1 is 3, minus 3. So we get half of minus 11. And half of minus 11 is 5.5 units squared. Area is squared. So keep in mind here, like I said, because those bars are here, that's telling me my answer is allowed to be positive, because obviously this is a real life problem. So you can't have a negative area of something. It doesn't make sense. So different example and a more challenging example here. So writing down our formula. But the problem with this is we do not have one of the vertices as 0, 0. So if our if one of the vertex is 0, 0, that means you can just sub in the other 2 coordinates to the formula. So we now need to move one of these points, so it's now a 0, 0. So I'm going to move 2, 4 to 0, 0. So if I was to look at my number line, okay, so we have 2, 4 is the point here, and we're trying to move it so it's now at the origin, which is 0, 0. So if we look at 2, we want to see what do we have to do to move to 0. And we need to subtract 2 in order to get 2 to 0. And if we look at 4 to get to 0, we have to subtract 4. Now, if we move one point of the triangle, we also need to move the other 2 points the same distance, because what we're technically doing is picking up the triangle over here and we're just moving it over to where the origin is. And what that means is it doesn't change the size of the triangle, and we're trying to find the area of the triangle. So by picking something up and moving it somewhere else, it doesn't change the area of the shape. So we now need to move minus 3, 1 and 3 minus 5 the same distance. So minus 3 minus 2 is minus 5, and 1 minus 4 is minus 3. 3 minus 2 is 1, and minus 5 minus 4 is minus 9. And now these are the 2 points that we now sub in to the area of a triangle formula. So we've half of x1, y2 minus x2, y1. So x1 is minus 5, y2 is minus 9, minus x2 is 1, and is 1, and y1 is minus 3. So we've half of minus by minus is plus, and 5 nines is 45. 1 times minus 3 is minus 3. Minus by minus becomes plus 3. So it's half of 48 which means our area of this triangle is 24 units squared. Now that's the last section of the coordinate geometry of the line chapter. So I'll send on questions based on the second and the third video, and we'll go from there.